Welcome to Thought Frontier.
Hey everybody, welcome back to another deep dive. Today we are talking about atmospheric water harvesting.
Oh, yeah.
This is a really cool one. And the main idea is pulling clean drinking water right out of the air.
Out of thin air. It sounds almost like magic.
It does. It kind of sounds like science fiction.
But it's not. And it actually has a really interesting and long history.
Oh, that's what I love about these deep dives. You never know where we're going to go.
Exactly.
So where do we start with this one?
Well, how about we go way back in time?
Okay.
Let's talk about the Incas.
Oh, wow.
Living high up in the Andes Mountains, above the rain line, they needed to figure out a way to get water.
Right.
And they did.
Okay.
They figured out how to harvest water from fog using something they called fog fences.
Fog fences. Okay, I'm picturing some kind of mystical barrier.
Yeah.
How did that work?
It's very clever, actually. They're strategically placed to capture the fog rolling in from the ocean.
Oh.
And as the wind pushes that fog through a mesh, the tiny water droplets collect.
Oh.
And then they trickle down.
And they could use it.
And they could use it.
So no pumps or electricity?
No.
Wow.
Just very clever design and natural processes.
It's a real testament to their ingenuity.
It is.
And understanding of their environment.
Absolutely.
That's amazing. And this isn't just ancient history.
No.
It's still relevant today.
It is.
Modern fog harvesting uses the same principles.
That's right.
That's so cool. There are definitely still parts of the world where fog is a consistent feature.
Absolutely.
Is there a good example?
How about the Namib Desert?
Okay.
It's incredibly dry, but researchers have found that fog collectors can yield over 2 liters of water per square meter per day.
Whoa.
Just by capturing the moisture from the coastal fog.
Wow, that's enough to really make a difference.
It is.
For people.
It is. It has the potential to provide a sustainable and decentralized water source.
Especially in those regions where traditional water sources are scarce?
Yeah, scarce or unreliable.
Yeah.
It could be both.
Right. But I imagine there are some limitations to fog harvesting. It can't work just anywhere.
Right.
Right.
You're absolutely right. It depends on a lot of things.
Right.
Wind speed, fog density, droplet size.
Oh, wow.
Even the mesh characteristics.
Wow. Okay.
It all plays a role.
It all affects how much water you can collect.
Exactly.
Okay, so efficiency depends on a lot of environmental factors.
It does.
What about the collectors themselves?
Yes.
Our research mentioned different types, like standard fog collectors and large.
The main difference is size.
Okay.
And really cost.
Okay.
A small standard fog collector, maybe about the size of a tabletop, would cost around $100 to $200. But a large one, like the size of a parking space, would cost around $400.
So when you scale up, the cost per square meter goes down.
Exactly.
Okay, that makes sense.
And that's when it gets really exciting.
Right.
Because these large-scale fog harvesting projects have been supplying entire communities with water.
Whoa.
We're talking hundreds of liters per day.
Wow.
There's even a nonprofit, FogQuest.
Okay.
And they install these systems around the world.
That's amazing. Seeing an ancient technique being used to solve modern water challenges is really inspiring.
It is.
But our sources also talked about some newer technology, right? Some stuff that goes beyond these traditional methods.
That's right. Scientists are always innovating.
Yeah.
And they're drawing inspiration from nature itself.
Oh.
It's called biomimicry.
I love that, learning from nature's best designs.
Yeah.
What are some examples in the water harvesting field?
Well, there's the Namib desert beetle.
Oh,
This little creature has evolved to survive in one of the driest places on Earth.
right.
And it has this bumpy back
Okay.
with a pattern of hydrophilic and hydrophobic areas.
So some that attract water
Yes.
and some that repel it.
Yes.
Wow.
So when the fog rolls in, the beetle's back essentially acts like a miniature fog catching system.
Wow. So the water droplets accumulate on those hydrophilic areas?
Yes.
And then they slide down towards the beetle's mouth because of those hydrophobic areas.
That's great.
That's incredible. It's a perfectly designed natural water harvesting system.
Isn't it?
And scientists are actually trying to replicate that.
Yeah, they're experimenting with things like spiderweb-like meshes,
Oh, wow.
fog harps with vertical wires, to catch those droplets,
Okay.
surfaces that mimic how plants capture and direct water.
Wow.
Lots of interesting stuff.
That is so cool. So both ancient and high-tech versions of fog harvesting, they can be really effective in specific environments.
Yeah.
But what about those places that don't have much fog?
Right.
Is there a way to harvest water from the atmosphere in those places too?
There is.
Okay.
It's called dew collection.
Dew collection. Okay.
And it has even broader potential.
Okay.
Dew forms pretty much everywhere.
Okay, so this is where my science knowledge gets a little fuzzy.
Oh, yeah.
How does dew collection work?
It's all about temperature.
Okay.
So when a surface cools down below the dew point, the temperature at which air can no longer hold all of its water vapor,
Okay.
that vapor condenses into liquid water, forming those tiny droplets we call dew.
It's like when you get condensation on a cold glass of water.
Yes, exactly.
But how do you, replicate that on a larger scale to collect enough water for people to use?
That's the challenge.
Yeah.
There are a lot of factors that affect how efficiently you can collect dew.
Okay.
Ambient temperature, humidity levels,
Okay.
wind,
Yeah.
even the type of surface you're using.
So you can't just, put out some cold surfaces and wait.
Well, you can.
But you have to be more strategic.
Exactly. Scientists are exploring all sorts of different approaches to dew collection.
Okay. Like what?
Radiative cooling surfaces,
Okay.
solar regenerated desiccant systems,
Okay.
and active condensation technologies.
Let's break those down. Let's start with radiative cooling. What is that?
Well, these surfaces are designed to radiate heat away as efficiently as possible.
Okay.
Think of it like a super efficient radiator.
Okay. But instead of heating a room
It's cooling itself down.
to encourage condensation.
Exactly.
Okay, so maximizing the surface's ability to cool down.
Yes.
Got it.
And that gets into some pretty interesting science.
Oh, does it?
Yeah, how materials emit infrared radiation, how reflective they are,
Oh, wow.
how to minimize the effects of wind,
Wind.
which can disrupt the cooling process.
Oh, wow.
It can introduce warmer air.
I see. So the choice of material would be pretty crucial here.
It is.
What's like a good example?
Well, aluminum surfaces have shown really impressive results,
Okay.
yielding as much as 3 kilograms of water per square meter per hour.
Whoa!
Yeah,
That's a lot.
it is.
Okay, and how does that compare to other materials?
Well, glass or polyethylene, those tend to have lower yields.
Okay, so choosing the right material can make a big difference.
Absolutely.
Okay, awesome. So what about solar regenerated desiccant systems?
Ah,
How
yeah.
do those work?
This combines the power of the sun with materials called desiccants.
Desiccants.
They're like super absorbent sponges,
Right.
but for water molecules.
Okay.
So essentially, they suck the moisture out of the air.
So how does that system work?
Okay, so at night, the desiccant is exposed to the air.
Okay.
It absorbs moisture. Then during the day, solar energy is used to heat up the desiccant,
Okay.
releasing that trapped water vapor, which is then condensed and collected.
So it's a two-step process.
Yes.
Using the sun to both power the system and release the collected water.
Exactly.
That's really clever. And that would be well-suited for arid regions.
Yeah, with lots of sunshine.
Yeah. Okay. And then we also came across active condensation technology.
Right.
How is that different?
Well, active condensation relies on external energy,
Okay.
usually electricity,
Okay.
to power cooling systems.
Okay.
So these systems force the air to reach its dew point, condensing the water vapor?
So it's more of a direct approach,
Yes,
but it requires a power source.
it does.
Okay, so each of these approaches, radiative cooling, desiccant systems, and active condensation,
Yeah.
they all have their pros and cons.
They do.
So choosing the right technology would depend on the location and the resources available.
Absolutely.
Of all the technologies we have talked about, there's one that really caught my eye.
Oh.
Solar hydro panels.
Ah, yes.
The source panels,
Yeah.
developed by Zero Mass Water.
Those are innovative.
They sound like something out of a science fiction movie. Panels that just produce clean drinking water
Yeah.
right on your rooftop,
I know.
powered by the sun.
It's amazing.
Is that actually possible?
It is.
Yeah.
Yeah, and it's not just a concept.
Yep.
They're actually being used all over the world.
Wow.
So these panels use solar energy to power fans and special materials
Okay.
that create a microenvironment for the water to condense.
And how much water can they actually produce?
Each panel can produce up to 10 liters of drinkable water per day.
10 liters.
Yeah,
That's amazing.
it is.
That could be a game changer
Absolutely.
for people who lack access to clean water.
Imagine the possibilities.
I know.
These panels could provide a decentralized, sustainable water source,
Yeah.
even in remote or water-stressed areas.
That's amazing. It's a truly incredible application of atmospheric water harvesting.
It is.
So it seems like this field is evolving beyond just individual use.
Yeah.
What are some of the other ways atmospheric water harvesting is being applied on a larger scale?
Well, the military is using atmospheric water generators
Oh, right.
to provide water in remote locations or disaster-stricken areas.
So when traditional water sources are compromised,
Yeah.
that makes a lot of sense.
Yeah.
Are there any other potential applications?
Oh, absolutely.
Agriculture.
They're using it to reduce water consumption.
So instead of relying on groundwater
Yes.
or rivers,
Right.
farmers could tap into the atmosphere to water their crops.
Absolutely. Especially in those arid regions where irrigation is a huge challenge.
That's amazing. Expanding the frontiers of agriculture.
It is.
But let's be realistic.
Sure.
Even with all this promise, there are economic realities.
Yeah.
Not everybody has access to this kind of technology.
Right.
Right.
You're right. The cost can be a real barrier,
Yeah.
especially for lower income communities or developing countries.
Right, where water scarcity is most acute.
Exactly.
So it's not just about the technology.
Right.
It's about making sure that it's affordable and accessible.
It is.
That's where collaboration comes in.
Absolutely. We need scientists, engineers, policymakers, and entrepreneurs
Yeah.
all working together
Yeah.
to drive down costs, develop those innovative financing models.
So that it benefits everybody.
Yeah, not just those who can afford it.
Clean water should be a right,
It should be.
not a
It
privilege.
should be a right.
Yeah. It's a future worth fighting for.
It is. And while there's work to do to overcome these barriers, I'm really inspired by the progress we've seen from the ancient techniques to those cutting-edge innovations. Atmospheric water harvesting is rapidly evolving, and it's exciting to see.
It's a reminder that human ingenuity can be a real force for good.
It can be.
But while we're celebrating the potential, it's also important to be mindful of the challenges.
Oh, absolutely.
We've talked about the energy consumption issue, the need for cost-effective solutions, the importance of adapting technologies to different climates.
Right.
How do we balance the excitement with the need for pragmatism?
That's a good question. That's where critical thinking comes in.
Okay.
We need to approach these technologies with a balanced perspective. We have to acknowledge both the potential and the limitations.
Yeah.
So it's not about blindly embracing every new development,
Right.
but carefully evaluating each one.
Yeah.
Its feasibility, its environmental impact,
Yeah.
its potential for positive social change.
So it's about asking those tough questions,
Yeah.
doing our research, being informed citizens.
Yes.
Right. We can't just assume that technology is going to solve all of our problems.
No.
Right.
It's about using technology responsibly and ethically,
Yeah.
making sure that it serves the needs of humanity.
And contributes to a more sustainable and equitable future.
Absolutely.
This conversation has given me so much to think about.
Me too.
It's not just about the science and the technology.
No.
It's about the human element,
Right.
the values that we prioritize,
Yeah.
the kind of future we want to create.
That's right.
And that brings us to another crucial aspect of atmospheric water harvesting, its potential role in disaster relief.
Yes.
We touched on that a little bit earlier.
Yeah.
How can this help people in emergency situations?
Well, imagine a natural disaster,
Okay.
a hurricane, an earthquake.
Yeah.
And that traditional water infrastructure is damaged or destroyed,
Right.
leaving people without access to clean water.
And in those situations, time is of the essence.
It is.
People need access to clean water for drinking, sanitation, basic hygiene to prevent disease.
Right. That's where atmospheric water generators can be so important.
Yeah.
They can be deployed quickly and efficiently to provide clean water.
Wow. So it's like having a portable water source that can be set up anywhere,
Yeah.
regardless of the existing infrastructure.
Exactly.
And as climate change continues to intensify, we're seeing these more extreme weather events, more frequent disasters.
Right.
The importance of these decentralized water solutions is only going to grow.
Absolutely.
So atmospheric water harvesting isn't just a technological innovation.
No.
It's also a form of climate adaptation.
You got it.
It's about building resilience and preparing for a future where water resources may be more unpredictable.
That's exactly right.
It's empowering to think we have this ability to take control of our water destiny,
It is.
to find new ways to meet our needs,
Yeah.
even as the environment changes.
It's amazing what we can do when we put our minds to it.
It really is.
Yeah.
It's a reminder that human ingenuity can be a powerful force for good.
It can be.
But there's one more crucial element we haven't talked about yet.
Oh, What's that?
The ethical dimension of atmospheric water harvesting.
Ah, yes.
What kind of ethical considerations do we need to think about when we're talking about taking water from the atmosphere?
Well, who owns it?
Yeah.
Who has the right to harvest that water from the air?
Right.
Is it a common resource that belongs to everybody?
Right.
Or can individuals or corporations claim ownership over the water they collect?
That's a really complex question. It gets into some murky territory.
It does.
Is there a risk that this technology could worsen existing inequalities?
It's a valid concern,
Yeah.
one we need to consider, especially as this technology becomes more widespread.
Right. So we need to ensure that it benefits all of humanity, not just a select few.
Absolutely.
It's not just about if these systems work. It's about developing ethical frameworks and policies
Yes.
to make sure that everyone has fair access and to prevent exploitation or environmental harm.
We need to have those conversations.
Yeah.
Open and honest discussions.
About the ethical implications of this technology.
Yeah.
And we need to include diverse voices and perspectives
Absolutely.
to shape its development and deployment in a way that aligns with our values.
It's about creating a just and sustainable future.
Yes.
For everyone.
This has been such an eye-opening conversation. Right. We started with how atmospheric water harvesting works, and now we're dealing with these big questions about ethics and sustainability and social justice. It's amazing how this one topic can connect to so many different aspects of our lives.
It's a fascinating topic.
It really is. Atmospheric water harvesting isn't just about solving a technical problem.
No.
It's about reimagining our relationship with water and with the planet as a whole.
That's right.
It's about challenging our assumptions, embracing innovation, working together to create a future where everyone has access to the resources they need.
I love that.
We'll explore that vision more right after the break. Stay with us.
I can't wait. Welcome back to our deep dive on atmospheric water harvesting. So we've talked about all this amazing technology.
I have.
But you might be asking yourself, why does all of this matter?
I mean, yeah, now I'm kind of curious, like, what are the bigger implications of all this?
Right. It really challenges the way we think about water,
Okay.
where it comes from, how we access it.
Right. Like, for centuries, we've relied on traditional sources.
We have.
Rivers, lakes, aquifers,
Yeah.
to meet our water needs.
And those are under a lot of pressure right now.
Yeah, with like growing populations and climate change,
Exactly.
we're seeing more and more regions struggling with water scarcity.
Absolutely. And that's where atmospheric water harvesting comes in.
Okay.
A new way of thinking about water.
Okay.
A way to tap into a source that's literally all around us.
The air we breathe.
Exactly.
It's like we've been surrounded by this like invisible abundance,
We have.
but we're only just starting to realize its potential.
Think about it this way. Imagine you're standing in the middle of a vast solar farm out in the desert.
Okay.
The sun's beating down, providing clean energy.
Right.
But what if that same solar farm could also produce fresh water?
Whoa, like a 2-for-1 solution. That would be incredible.
Researchers are exploring ways to combine solar energy and atmospheric water harvesting
Okay.
into these synergistic systems,
Interesting.
creating that win-win situation.
Like those source hydropanels we talked about.
Yes,
The ones that produce drinking water right on your rooftop.
those have a traditional solar panel right in the center.
Oh, wow.
So while they're pulling moisture from the air, they're also generating electricity.
That is so smart.
It is.
So it's not just about developing the individual technologies,
Right.
but also finding ways to integrate them for maximum impact.
Yeah, a holistic approach to resource management.
Yeah,
That's what we need, especially as we face the challenges of the future.
for sure. And the potential of atmospheric water harvesting goes beyond just like drinking water and sanitation.
It does.
What about agriculture?
Yeah, especially in those arid regions where water for irrigation is scarce.
Right, so instead of depleting groundwater or putting a strain on rivers, farmers could use the atmosphere to water their crops.
Imagine the possibilities.
It's exciting.
It could transform how we grow food in water-stressed environments.
Make agriculture more resilient and sustainable.
Exactly.
Potentially open up new areas for farming that were previously unsuitable because of a lack of water.
That's right.
Wow, okay, that's
Wow.
huge. But let's be realistic for a second.
Okay.
As promising as this sounds, there are like economic realities.
Yeah,
Not everyone can afford this technology,
you're right. The cost of implementing these systems can be a barrier.
especially for low-income communities,
Mm-hmm.
developing countries.
Right. The places where water scarcity is often most acute.
Right. So it's not just about the technology itself.
No.
It's about making it accessible and affordable for everyone.
It is. That's where collaboration comes in. We need everybody.
Yeah.
Scientists, engineers, policymakers, entrepreneurs,
Yeah.
working together to drive down those costs and develop innovative financing models.
So that everyone benefits.
Not just those who can afford it.
Yeah. Because clean water should be a right,
It should be.
not a privilege.
Absolutely.
It's a future worth fighting for. And I know there's a lot of work to do
There is.
to overcome these barriers, but I am really inspired by the progress that's been made.
Me too. It's amazing to see how far we've come.
I know.
From those ancient techniques to all the new innovations, this field is evolving so rapidly.
It's exciting. It's a reminder that human ingenuity can be a powerful force for good.
It can.
But as we celebrate the potential, we also have to be mindful of the challenges, right?
Of course.
They've talked about the energy consumption, the need for cost-effective solutions, the importance of adapting these technologies to different climates.
Right.
How do we balance the excitement about this field with the need to be, like, pragmatic and realistic about those real-world limitations?
Well, it's about being thoughtful, approaching these technologies with a balanced perspective,
Okay.
acknowledging both the potential and the limitations.
So it's not about just like, yay, new technology.
Right. It's about carefully evaluating its feasibility, its environmental impact, its potential for positive social change.
So we got to ask those tough questions.
We do.
Do our research, be informed citizens.
Yeah.
We can't just assume that technology alone is going to solve everything.
We can't. It's about using technology responsibly.
Ethically.
Yes. Making sure that it serves the needs of humanity.
Contributes to a more sustainable and equitable future.
Absolutely.
This conversation is really giving me a lot to think about.
Me too.
It's not just about the science and the technology,
No.
but about the human element, the values, the kind of future we want to create.
Absolutely. And as climate change intensifies,
Yeah.
and we see these more extreme weather events and disasters,
Yeah.
the importance of having these solutions in place is just going to grow.
So it's more than just a technological innovation.
It
It's
is.
a form of climate adaptation.
It is. Being proactive,
Right.
anticipating those future challenges,
Right.
developing solutions that help us mitigate the impact of climate change, and build a more sustainable future.
It's like we can actually take control of our water destiny,
In a way.
finding new ways to meet our needs, even as the environment changes around us.
I love that.
That's amazing.
Mm.
It's a reminder that human ingenuity can be a powerful force for good.
It can.
This has been such an eye-opening conversation.
It has.
We started with the nuts and bolts of how atmospheric water harvesting works.
Yeah.
And now we're talking about ethics and sustainability and social justice. It's amazing how one topic can connect to so many different aspects of our lives.
It's a fascinating field. It really is. It's not just about solving a technical problem. It's about reimagining our relationship with water.
And the planet as a whole.
Exactly. Challenging our assumptions, embracing innovation, and working together to create a future where everyone has access to the resources they need to thrive.
And we will explore that vision in more detail after a quick break. Stay with us. Welcome back to the Deep Dive. It's incredible how much we've covered about atmospheric water harvesting.
I know.
We've talked about the ancient Incas, cutting-edge science, desert beetles, solar hydropanels, and the ethics of it all. This could really change the world.
It really could.
But what I'm most struck by is this new way of thinking about water that it offers.
It makes you think differently about something we take for granted.
Right.
Like water, we're used to finding it in rivers and lakes and underground.
Right, yeah.
But with atmospheric water harvesting, we can create it.
Exactly. We can make it right where we need it. And you've said how big of a deal that could be.
Yeah.
Especially as traditional water sources become less reliable. We talked about how it could change agriculture, disaster relief, maybe even power plants.
Yeah.
What other things do you think of when you imagine this future where we can just make water?
I think about community resilience, especially in places where water is scarce. Imagine a village that depends on a well that's drying up, or the water is contaminated.
Right.
With this technology, they could make their own clean water
Yeah.
right there,
Wow.
using renewable energy.
So they wouldn't have to rely on outside sources.
Exactly. Sources that might not even be there anymore.
It's like they could control their own water destiny.
Yeah. And it's not just the water itself.
What else?
It creates a ripple effect.
Okay.
Think about it. When people have clean water, their health improves.
Yeah.
Sanitation improves.
Right.
Kids can go to school instead of spending hours collecting water.
It changes everything.
It does. It can build better lives.
It gives them the power to thrive.
Exactly.
Yeah.
And this goes beyond just individual communities.
Okay.
What if we could reduce conflicts over water resources?
Oh, wow.
In so many parts of the world, water scarcity causes tension and violence.
It's a huge problem.
It is. But imagine if we could take some pressure off those traditional sources.
By creating new ones.
Yeah.
That's a really important point. More water could mean a more peaceful world.
It could. It all starts with that shift in thinking.
Right.
From water as something scarce,
Yeah.
something people have to fight over,
Right.
to water as something renewable.
Something we can make.
Right, something we can share, manage responsibly.
For everyone.
Exactly, for the benefit of all.
This conversation has made me realize how incredible human ingenuity is.
It's pretty amazing.
We face all these problems, but we always come up with new ideas.
We do.
We adapt. We find solutions.
We do.
And atmospheric water harvesting is a perfect example of that.
It is.
We're learning from nature,
Yeah.
using science and technology, working together to solve these complex problems.
It's inspiring.
It is.
Yeah.
But it's important to remember that technology alone isn't enough.
It's not.
We have to be careful.
Yeah.
Think about the ethics.
Absolutely.
Make sure it benefits everyone.
Everyone, not just a few.
Exactly. So as we finish up this deep dive,
Yeah.
I'm feeling really hopeful and excited. We've explored this technology that could change so much.
It's a powerful technology.
It could transform lives, change industries, help us deal with some of our biggest challenges.
It really could. As we move forward, let's remember what we've learned.
Let's approach it with curiosity.
Yes, curiosity and responsibility.
Yeah.
And make sure it helps those who need it most.
It's been an amazing journey,
It has.
and I hope you, our listeners, have discovered something new about this incredible technology.
Me too.
Thank you for joining us on The Deep Dive.